Welcome. In this video, I'll be calculating the sample size n required to estimate the population mean mu. Recall that if the population standard deviation is known, then the margin of error E is z times sigma over square root of n. At 95% confidence level, the z critical value is 1.96. Suppose the population standard deviation is 8. For a sample size n equals 40, the margin of error is 1.96 times 8 divided by the square root of 40, which gives 2.48. If the sample size were 50, then the margin of error will be 2.22. And if the sample size were 60, then the margin of error will be 2.02. These results show that as sample size increases, the margin of error decreases. And that should be expected since n is in the denominator, and also because larger sample sizes should be more reliable and thus produce smaller errors. Now, if we intend to calculate the sample size needed to keep the margin of error at a particular value, we can solve for n in the error formula to obtain the square of z sigma over E. So for example, to find the sample size required to estimate the population mean to within 1.5 units, where the population standard deviation is 8 and at 95% confidence level, we substitute the values into the sample size formula to obtain 109.3. Since the sample size is the number of observations, it should be a whole number. So if we round 109.3, we should get 109. But then a sample size of 109 will not be enough. The result shows that we need more than 109. Thus, we always round to the next larger whole number. So the sample size needed here will be 110. Now suppose the confidence level were 90%, then the z critical value will be 1.645. And that will produce a sample size of 77 when rounded. That is, to estimate the population mean to within 1.5 units with 90% confidence, the sample size should be at least 77. And that's how to calculate the sample size required to estimate a population mean. Thanks for watching.